Quarter zips and matcha, that's what life's about. All right, so we are looking on today's video. Fortunately, we all had issues, or unfortunately, I don't know the right way to word this. Okay, computer, what are you doing? I had to restart it last hour, so we'll see what shakes out. Oh my goodness. Okay, there we go. Sweet. So, boom. We are going to work number 4. Now, if you're not checking, like, you guys are cool to work it on the back of your page if you want to rework the entire problem. Probably not going to hurt anybody, I'm sure of it. And I don't think I made a mistake, but we'll see. Okay, we have a population of mice that's introduced into a new environment. And 14 weeks after we introduce them, we find the population to be this. 4 weeks later, the population is this. So assume that we get the resources so that they don't run out and starve to death. Cool. Okay, right away, the very first thing that I'm going to do, and you might have seen this already, is when the problem is written with context, it can be kind of confusing to think about. Let's remove the context first. And this is abstraction. We are generalizing something out farther. So let's just get away from the context, and then we'll bring our context back for our answer. Do you know any, if we were to plot this, can you give me any ordered pairs that would be on this graph? At 14 weeks, which is time, that's usually my independent, I have a population of 90. 190, thank you. We would have gotten a very wrong answer. Thank you, I appreciate that. Any other values? 18, what do you mean? It says 4 weeks.
4 weeks
Later, okay, so we're at week 14 and we go 4 more weeks and then we're at week 18. And now we get 268. Because we were at week 14 and then we go 4 weeks later. What is going on here? That's an 8. What are you guys talking about? And that's always how I draw my 8s. Okay. Deal. So we're trying to find a working exponential model that will allow me to predict the number of mice. Now, fine, we'll predict it. What's an exponential model look like? AE to the KT, and I don't think I recorded. So we all just agree that it's y equals AE to the KT. Now, do you want to use this? Do you want to change the letters to make sense in the problem, or are you cool with these? Only thing that I would possibly change is I would use a P for population instead of Y. I'm just going to keep it Y for now. Okay. Well, to have a model, I need to know how many did we start with, and I need to know K. Those are the 2 things. We have 2 unknowns, and how many equations? Where do you see 2 equations? So maybe eventually, and that's probably what you're thinking. Right now, do you guys agree we only have 1 equation, and that's an issue? Yeah. All right. So let's just see if we can't work it out. Do we have a T and a Y that we can plug in anywhere? Do you know the population at any time? Hey, I know the population is 190, so I'm going to use this point first. 190 is the population. When I start with, I don't know how many, we'll call it A. I'm going to make that a little bit more bold. A, E to the KT, and I'm just going to write K over here. How much time did we have to go to get to 190? Do we all agree that this is just rearranged to look nicer? Mm-hmm. All right. Now, it doesn't really matter which way we go. When we did it in class, I know the direction that I went. Can I solve this for A? And it won't be a number, but can I solve it? Yeah. Okay, so I think that we get A is equal to 190 divided by E to the 14K. Everybody cool with this? Now, we could have done it the other way, but this is the way that we did it in class. It's the way that I traditionally do it. We could solve for K and then try to do it the other way, but this is going to work nicer, I promise. Okay, so we just did that. Now, if I knew K, I would get a value, but I don't know K. But do I know another point in time and another population? Oh, hey. At 18 weeks' time, here's a population of 268. So let's use that. 268 is equal to, well, I still don't know A. Not exactly. But do we know what A is? What is it? It's 190 over e to the 14k, whatever that is. That is the value of a. And we still multiply by e to the, what week are we at now? 18, and there's still a k here. Now, by doing this, we have boiled our problem down. We had a single equation with two unknowns, and there was trouble. How many unknowns are in this? One, and one equation and one unknown is wonderful. So, thanks. As we're looking, I'm not going to rearrange it, but if I multiplied, would this e to the 18k, would it go to the numerator or the denominator? The numerator. And then what happens if I have a base to some power divided by the same base to a different power? What do these exponents do? Subtract. Without rewriting it in that form, and I wouldn't if I were you, but if somebody heard that and they didn't understand what I said, here's the intermediate step that I typically wouldn't show. This is just 190 times, and I'm going to write it like obnoxiously, e to the 18k over e to the 14k. I'm using the fact that I can rewrite it like this to make it very clear how my exponents work. Have I lost anybody here? Okay, so using that, I'm only going to use green moving forward here. I obtain then 268 is equal to 190 e to the how many k? If we have e to the 18 over e to the 14. E to the 4k. And now it's just a matter of solving it for what? 4k. So I'm going to do small steps. If I want to isolate k's to just one side of this equation, the very first thing I do, let's divide by 190. Now, I'm going to show all my steps, but I'm going to take big steps, and I'm going to leave an awkward gap here for just a second. E to the 4k. And it's a very intentional awkward gap that I've just left because I don't want to have to rewrite the exact same line for what I'm about to do. Speaking of, what am I about to do? I'm about to take the natural log of both sides. Why would I take the natural log? Not the e. No. I mean, it will fall out, and that's convenient to get k out of the exponent. And in the process, you're right, Lay, that it will get rid of the e, which is just a bonus. So I've left space to do that, which is pretty sweet, and I'm just going to do it. If I take the natural log of the left side of this equation, then algebra says that's fine as long as you take the natural log of the right side of this equation. Okay. Can I skip one line in simplifying this? Normally, and again, so just in case, I think you should, just so you know. I do think we should all skip this line, but you might not be comfortable in doing so. If you want to show the intermediate step, I'm just going to do it all in yellow. We'd have the natural log of 268 over 190. And what happens with exponents when they're in the argument of a logarithm? That's a big question. There's a lot of words in there. Where do they move? So kind of. We're going to get there eventually. I'm just trying to show this middle step. Take these guys and get them out front of everything, like every time. We would, and again, I don't think that you should typically show this, but this is the power rule for logs, and it's just how we rewrite them. Okay, I would skip this step normally because e to what power gives me e? It's the 1. Now, I've just used the power property and the fact that they're inverses. What I would rather you guys use, and it's entirely up to you, if I see an ln and an e, they just undo each other and the 4k falls out, which in the end, the same output, right? Same thing happens. One step away, how do I solve 4k? So we're going to take, I'll go back to green. Sorry about that. Do you guys skip this step, the yellow one? Okay, good. Is it okay if you don't? Absolutely. So k is, and I hate the way that k looks. So k, I don't know why I can't draw it. Whatever. K is exactly equal to the natural log of 268 over 190 divided by 4. And let's see, 0.085991. 0.085991, I think. Okay, I'm fine with that. So we now have an approximation. K is approximately, and obviously I was looking down and just making sure you couldn't see my eyes looking at my page. Didn't calculate it in my head. 0.08599. 0.08599. Now, realistically, I could have written more decimals, and Leigh, I'm going to pick on you because I saw you trying to write like 30 of them yesterday. I'm just going to let my calculator write 30 of them, realistically. When I do this next calculation, I'm not going to use this number. I'm going to scroll up on what this number was in my calculator and use all 16 digits, but there's not a chance I'm going to write all 16 of them. Okay, so the one little thing that I'm going to do, and I'm going to really be clear about the annotation, why we needed K to get our model anyway, but more before even having the whole model, we needed K to get a value for what? So I'm going to switch to this lovely blue, and I'm just going to, along this line, we'll say use K value that we just found to get A. Like, that's what we're doing. And it can be weird because we go back and forth in these problems, but this is exactly what we're doing. With that said, I know that A is exactly equal to 190 divided by e to the 14k. And on your calculator, if you've already done k already, or if you haven't, if you want to just see we get the same value, I would get this value on my calculator, and then when I type this in, I do e to the power of 14 times, and I would just scroll up until it's highlighted, and I would type it so I get all 16 digits. I think, whether you do it or not, you should verify, just so you know, but I think we're going to get an approximation for A that is what? Keep going, 57 point. So 57.006 something. Okay. What is the context of this problem? And now we're going to come back to it. It's mice. Can you have 6 1,000ths of a mouse? It's 57 mice, right? Like, you can't have a 6 1,000th of a mouse. You could, but you wouldn't call it a mouse, I don't think, if I gave you that. Okay, so I'm going to use 57 is what I'm going to use. Whole numbers for populations. Do we have K? Do we have A? Can we write a working model then? And here it is. So we get the model y is equal to 57 e to the 0.08 or 0.86. What do you want to go to? 599, I'm fine with. T. Boom. There were 3 points here on this problem. Your 3 points, that if this were a test, like normal test, I'm going to give you a point. Did you get a value for A here? And theoretically, is it the right value? If it's a wrong value, I probably wouldn't give you the point, and I would just see what did the rest of your problem do. You get a second point for did you get not only this, did you get a value for K? Your third point, and it could be worth 4, but I only have 3 on mine. Your third point comes from, did you use this K to get an A, and did you plug it in to give me a model? There's your 3 points. Okay.
We immediately started out doing like this. Like this. My answer.
Good. So you just use the fact that this is a gap of 4. Yep, I'm fine with it. I'm not going to talk about it with everybody, but I'm fine with it. Yep. Because it doesn't matter as long as there's a change of 4, you're going to change by the same ratio with an exponential because it's how they work. Like, it's a big ratio, but it's the same. You guys are fine. This is the more drawn out way to do the problem, but I also do think it's a more natural way to think about it. But I agree with you. Okay. When we use this model, and this is part B on the next page, 2 points. Did you do it, and did you give me a context? And I'm not going to type this into my calculator if you guys are cool with it. This is the model that we use, right? Okay, if I want to predict how many mice there will be after 1 year, which, here's a reminder just in case you didn't know it, is me checking after 52 weeks. Do we have a different problem?
Where did you get 174?
Whoa, typo. Disregard. Yep, typo. I have no idea because I wrote 57 on the last page. I don't know. If this is at 54, we'll check real quick. Good call. 57 is what I said. What's 57 times e to the 0.08599 times 52?
4,987. I didn't round up.
What's the real decimal? 4987 point something?
86.708.
I'm going to call it this. If you call it 87, don't count it wrong. But if I give you 0.6 of a mouse, you're probably not going to say it's a mouse. Is that number wrong?
Oh.
Are you, so what's your number? You're fine. Okay, here's the deal with it. With the rounding stuff, we're going to get a big difference whether we round to 3 decimal places or we round to 10. There's going to be, like, you're going to get, with this small of a number, probably like 10 to 15 difference. If you are close and it's just due to a rounding error, I'm probably not even going to dig in close enough to see where your error happened. I'm going to count it. Like, I would always encourage you, don't round until the very end. Like, if your calculator gives you 16 digits, do the thing where you scroll up and just hit enter, use all 16 of them. I can't remember if that's what I did. Doesn't matter because I used the wrong number anyway. But 4986, roughly. There's a plus or minus 10 in my head as I'm looking at them, just so you know. Okay, so your second point with the right number would come from after 1 year, there will be approximately, not that many mice, because again, I used the wrong thing, 4,986, or as long as plus or minus 10, I'm going to give you the credit for it, mice. Okay, remember, you can't say there will be, you have to say after 1 year, give the context. I'm going to let it slide on the practice test, but you need to write the most annoyingly specific answers when you're doing word problems. Okay. Easy, feel better about it than you did, feel worse. I'm good with that. Yep, as long as you have the after 1 year part in there and you're specifying what it is, I'm good. Okay, on these, it's just try and were you right. Now, you might have gone further than this, but I don't know if anybody in here did. Is this what you guys have? You go a step further? Okay, I'm okay with this. And this is like, there's some, I wish I could be very clear with like what exactly do I want. At least no more expansions in the logs themselves is really what I'm after. You might have this 2 ln of y minus 1 minus 2 ln 4. Or you might look at this and say, well, that's dumb because that's 2 squared. So another 2 comes out. And you could say, oh, it's really 2 times the natural log of y minus 1 minus 4 natural logs of 2. And if you don't see what just happened, and it's weird, do you agree that 2 natural log of 4 could be written like this? And then the 2 just goes out front again. And now it's 4. Or you could feel crazy and you could say natural log of 16. Because the 2, if it's in front, it was a power. Like, I would just go here. If you can't do any more logs, stop. I might have made that less clear, maybe, Karina. I can't tell. Okay. You guys probably have this one. Yeah. I'll trust you. Like, if there's, again, if you can't write another log in it, you're probably done enough. This one, we probably have the same answer. 2 ln x plus 2 ln y plus ln z. Okie dokie. I'm not going to lie, this is the first time I've seen the sun in like 5 days, and I'm like nirvana right now. All right, so we're condensing. My hope is you guys stopped here.
Yes. No, wait, what?
So, as long as you don't have x to the 5th plus x cubed, your group, if you expanded, did you FOIL? Okay, here's the deal. I'm cool with it. Again, same thing, condensing just means write as a single log. You can play the algebra game as much as you want, but here's the only thing. Because you guys went further, the only way that you're not going to get your points is if you have x to the 5th plus x cubed. If that's your whole argument, you're wrong. And you freshmen dreamed. Based on your face, I don't think that's the... Okay. Yep. Because you got to do x cubed times x squared plus 2x plus 1, and then you got to FOIL it out again. Stop here. 1 log. I'll even make sure the directions on your test say condense the following to a single logarithm. Okay. Is this what your b looks like? I don't care if you have a square root or if you have a 1/2. I'm okay with either. Yep, I'm good with it. Again, if you didn't catch it just a second ago, Well, on the actual test, the directions will say condense to a single logarithm. Yep, just so that like don't simplify it. It's good practice, and there's nothing wrong if you did it. There were 10 points on this page. All right. On number 6, this was my bad. I did not, like, clearly there was a weird enter thing that happened because I have all this room on the back, and then I left you guys this much room here. That was an accident. I don't know what happened with my formatting. Okay, on A, I think I'm right. 395.429? Okay. And on Charlie, let's see. I divide both sides by 4. I raise or exponentiate each side with base e, or I use the definition of a log. You can't even tell. I then divide by 3, and we get approximately 14.174. Okay, here's the fun thing. On the actual test, there's a 0% chance that I tell you to round your answer. I want exact answers on the test. They're so much nicer to check. Question? What did you do? What's your answer? Appreciate that I'm nice. Okay. On B, did you get 1 and 3? That's okay. So because I'm going to, like, when we get to trig stuff, I'll be more hardcore about it. I usually go to 10,000, so I can't think of why I would possibly have thousands on this. The test will be exact answers. I don't want you to type it in your calculator because I don't want to have to read your ugly decimals. Okay. And on delta, did we get 5? Okay. Was 7 also a challenge? That's the key. And like I think I made a big deal about it in class. I think. Okay, notice the very first thing that I did, and there's a lot of points here. The first one is, did you choose to use an exponential model? Like whether you physically wrote y equals a to the kt or not, I don't know. You probably did because I do it. So I imagine you guys did, but you might not have. Okay, there's a point. Did you use an exponential model? And then I hope that we both did, or all of us did the exact same first step. Before anything else, boom. Here's our shortcut for k. Natural log of 1/2 over half-life every single time. Now, I then make some other notes and I try to color code it nicely. What's up? Okay. I know that y, my final amount, is 0.4 grams. I know that I'm trying to check out 1,000 years. So then I don't care if you actually had these written down, but is it very clear that there's somewhere on your page, either as a result or hopefully with some work shown, that you've used the information they've given you here to get 0.4117. So depending, here's where the grams part, because I might be kind of a monster here. If you don't have grams right here, that's okay. You have to have grams here. What did you say? I'm going to let it ride this time. But on the AP test, just so you know, if you don't say grams of what, you're probably not going to get the point. I will not give you -1 if you left off your grams here, if you give me a sentence. As long as there's grams here, I won't take off points if there's no plutonium-239, whatever way you wrote it. I care, did you try to write a sentence? And we'll all start being crazier and crazier about, is that sentence good enough moving forward from here? Like, it's good practice. Okay. So 4 points. Did you use exponential? Did you use the info I gave you? Did you get a value for A? And did you try to write it in a sentence at least? Okay, on the test, just so you know, if you write me a sentence and you don't include grams, I'll take off a ½ point. If you write the sentence and you don't tell me what is left, like there's plutonium or holowonium or whatever it is, I will take off a ½ point. If the context is attempted but not perfect, and there's a lot of different ways it could be perfect, but I will take off a ½ point for it. Okay, how much is left after 10,000 years? Check it out. Here's my initial. Here's my k value that I didn't want to use an ugly decimal. I just used this. And here's my time t. I get 0.0232. There will be approximately 0.232 grams of plutonium-239. Would I get full credit on my test? I don't think I would. after 1,000 years.
So I don't have to include the P.
You should say of whatever it is. Don't count it wrong in the practice test.
100,000.
Boom. Perfect. Okay, 15 points there. Last page. Did we do a problem like this ever? I don't think we did. Not in this section. And yeah, which I just want to highlight, like, that's awesome.
Oh shit.
That's not what I'm highlighting. What's your point of intersection? Negative 311. So this one's always weird. Here's how I would grade this on a real test and how, like, I want you guys to check it. Did you really try? And when I say try, I wasn't specific, but I mean, did you try to solve a system of equations using a method that's valid? Didn't write that, but that's what I'm looking for, substitution or elimination. Did you get X and Y correct? Like, that's the other part. And then, did you write them as an ordered pair? If you got X and Y wrong, there's a 0% chance that your ordered pair is going to be correct. But if you found the wrong X and Y and then wrote it in the correct format that it should be, I'll still give you a point because the notation's important also. Okay, there were 3 points on the back, which means there were 11 on the front and then 10 on page 2, which means we're at 21. Now we're at 36, and 3 more puts us at 39, not 36, so take that test. What I want you to do for me real quick is I want you to write minus however many. And then once you write minus however many, write the this many out of 39 is what your percentage was. And then I need to borrow those for about 5 minutes because I'm going to put them in the grade book. Okay, we got about 10 minutes left in class. I'm going to pause the video temporarily. Have I been recording? It looks like I am. I am recording, but it's gone for some reason. Oh, there it is.